Now we're going to switch topics for just a bit and talk about organometallic reagents. But once we do this, we're going to tie these back into how they react with carbonyl compounds like aldehydes, ketones, and carboxylic acid derivatives. Here are two common organometallic reagents. The first is known as a Grignard reagent. And a Grignard reagent takes on the general form some R group with a magnesium halide, usually a bromide. In this case, the R is a vinyl group, but it can really be any R group. The second one is an organolithium compound. And this takes on the general form R bonded to lithium. So what this metal does is it gives a significant dipole toward the carbon. So in the case of lithium, or in the case of the magnesium, there's a significant dipole toward the carbon, meaning the metal is partially positive, the carbon is partially negative. What we're going to do to really simplify this is actually break these down and simplify them into cations and anions. So in the case of the Grignard reagent, we can simplify this as the double bond with a lone pair and a negative charge on the carbon, and the spectator ion MgBr+. For propyl lithium, we can simplify this as a propyl anion and lithium plus. So now what we see is that these are going to be carbon nucleophiles. And they happen to be good bases. Our focus is going to be on using them as nucleophiles, but if you put one of these reagents in the presence of an acid, this lone pair is going to act as a really strong base to take that proton from the acid. So let's look at how a Grignard reagent and organolithium reagent can be prepared. Grignard reagents are pretty simple. So what we do is we start with an organohalide. So let's say we want phenyl magnesium bromide. So what I would start with is just bromobenzene. And you know how to prepare that from benzene. From there, all we do is add magnesium, and the magnesium inserts itself between the carbon-bromine bond. So there's the Grignard reagent, and of course in this case, if we were going to use this, we could treat it as just a benzene nucleophile. For an organolithium compound, let's say we want butyl lithium, I can start with an organohalide like butyl bromide, and I need 2 equivalents of lithium metal. So remember, lithium is in group 1A of the periodic table versus magnesium, which is in group 2A. So magnesium can form 2 bonds, lithium can only form 1. So what happens here is the lithium will substitute the Br, so it replaces it. The second equivalent of lithium just gives you lithium bromide as your byproduct.